All right, just going to get more practice with inequalities. So not really adding anything to it. Going to do a couple with word problems, so that'll be a little bit different, but not a whole lot. All right, so start with that one. Go ahead and solve for x. Sarah E., what you got? We'll put the variable first, though. All right, so nothing to distribute, no like terms, so we're going to move the variable. I got 5x, I got 8x. Move the 5x by doing opposite. So we're going to subtract 5x from each side. When you move the variable, you want to cancel it out on one side. And that's what we're doing there. So 8x minus 5x gives me 3x. I got the plus 1. And the left side just has a 16. After you get the variable to one side, you're trying to get the variable by itself. You want to isolate the variable. So we move things away from the variable by doing opposite. Start with your addition or subtraction. So we subtract 1 from each side. Then after that, you divide. As I said yesterday, though, answer choice is going to always have the variable to the left. So we got to always flip those around. Pointy part of our inequality sign was towards the x, so we need the pointy part towards the x for our answer. And then we got the 5. So we got x is less than 5. Any questions on that? I'll give that one a try. A little more complicated. Gray, what you got? X less than or equal to 9 is correct. So we distribute on both sides. So we got minus 4x. That becomes plus 20. And then we got 2 minus 2x. When our variables are both negative, you want to move the one that looks like, is bigger negative. We're moving the lower number coefficient each time. So I add 4x to each side. Cancels there, which is what we want. So we got 20 greater than or equal to 2 Now the signs are different there, the minus 2x and the 4x. So we subtract, use the sign of the bigger number, that becomes a plus 2x then. And we're just solving, doing opposite. Addition and subtraction first. So we got 18 greater than or equal to 2x, divide by 2. And then we flip it around. Okay. Any questions on that one? So not maybe a ton complicated, but a little bit more than the one before. All right, so now we're going to look at a couple word problems. Just like with the equation word problems, where you didn't have to necessarily write the equation, you don't necessarily have to write the inequality. Sometimes it's helpful though. But Sue has $5.50 to spend on lunch. She buys a hot dog for $2.75. If chips cost 75 cents per bag, what is the most amount of chips she can buy? Sydney? 3 is correct. All right, there's a lot of different ways you could do this. I'm just going to show you the inequality to start with, though. We got a hot dog for $2.75. Plus, she's got 75 cents for each bag of chips. And we don't know how many she's buying, so that's a variable multiplied by that. She has $5.50 to spend. Y'all, if she's got $5.50, can she spend exactly $5.50? Yes, she can. You can spend all your money. I mean, buying these things, she can't, but you can spend all your money, so it could always be equal to, right? All right, can you spend more than $5.50? No. Could she spend less than, though? Yeah, so our inequality would have less than. There are some problems you see occasionally where it asks you for the inequality and gives you like 4 inequalities as answer choices. Sometimes it's as easy as just finding the one with the right inequality sign. All right, so if you look there, in this case to solve it, you would subtract 275, and then you would divide that by 75 cents. And you would end up with a decimal, like 3 point, I don't know, something. So that'd be one way to do it. She can't buy like half a bag of chips. You know, the store's not going to let you dump out half the bag and only buy that, right? Not how things work. So, other way, possibly easier. To me, the way I did it is I started with $2.75, which was the price of the hot dog, and just added 75 cents until couldn't anymore. So she didn't have enough money. So if you went $2.75, you go to $3.50 for one bag, $4.25 for the second bag, and then $5 for the third bag. She's got 50 cents left. So that'd be another way. A few different ways you could do similar to that as well to get an answer. Any questions on that one? All right, let's try another one. We got Bill. He's got $75 for clothes shopping. Buys a pair of pants for $35. We need the most shirts he can buy for $9. Zion? Kari? 4 is correct. All right, so pants. Each shirt's $9. Same as before. A lot of these, whenever they deal with money, usually going to be like a less than or equal to situation. And that's what we would have. This is one you probably could fairly easily solve. You subtract 35, you get 40. Y'all, how many times 9 go into 40? 4 times with, 4 left over, right? So similar to the one before, different ways you could do this by adding or subtracting the $9 kind of thing. So just kind of depends on that. Any questions there? The word problems, I think, are actually easier than when they give you like the actual inequality a lot of times, or at least in my opinion. All right, go ahead and give this a try. Mason? A is incorrect. Kari? Nope. It's not one of the answer choices. When you go to solve this, you get x is greater than 4. Is everybody good with that part? Anybody need to see me work it out to solve it? All right. Couple places where y'all screwed up. 1, reading comprehension. What's it ask you? Yeah, Sari. Whoops. I still obviously can't figure out how to fix what's going on with the board. So we get fun stuff like that. Anyhow, well, that's a 4. That S makes a difference, doesn't it? What's that S mean? More than 1. All right, so now when we look at their answers, we got x greater than 4. Y'all, is 4 greater than 4? No. If there was a line underneath our inequality symbol, then 4 would work. Y'all, is 8 greater than 4? Yeah. So B works as a solution. Is 9 greater than 4? Yeah. So that means C works. Is -2 greater than 4? No. So that one doesn't work either. Everybody kind of follow how those work? If you have an inequality and it asks you for which one's a solution or which ones are solutions, what you're looking for is what makes the inequality true, okay? In most cases, it seems like those are problems that are trying to trick you a little bit. When you solve it, one of the answer choices will be the number you get when you solve it almost every time. There are some exceptions, but most of the time it will have the one you get. Like we had 4, 4 was one of the answer choices. That's to make you kind of pick 4. I said to kind of maybe trick you a little bit. The actual answers are what makes the inequality true, though. Okay? Everybody good there? Good chance check-in or EOC has something like that. Definitely got something like that on your test, though.